welcome everyone for our webinar. My name is Dinesh Pandey. I'm a researcher in soil carbon and nitrogen cycling at Rodale Institute, based in Pocono Organic Center, Long Pond, Pennsylvania. Today, I'm going to talk about ecosystem services of regenerative organic agriculture practices. And since we have a diverse nature of audience, I try to make my presentation as simple possible. I'm including information such as why should we care about ecosystems? What are those adaptive practices which support soil health, etc. To start our presentation, I'd like to first run with a kind of ice-breaking activity. Please type in a chat box that what comes in your mind when you see this picture. Please share your any thoughts within next 2 minutes, please. So you can type in your chat box that what you can see or what comes in your mind when you see this picture, please. Okay, you can still type your thought, but let's get started. I'm going to start with some terminology that which is very related to our presentation today. For example, ecosystem. The ecosystem, the meaning is household or place to live. Ecosystem which provides benefit or services for us. And another terminology is ecosystem services. That is also known as the multitude of benefits that nature provides to society. That means anything which makes human life so possible or easy. For example, when you get support from the honeybees or any pollinators for a pollination of the crop, or when you get any support for the soil formation, that is a type of ecosystem services that you are getting from the nature to make human life possible or feasible. Similarly, the biodiversity, we can define it the diversity within and among species and ecosystem. So biodiversity, what happens is when we have more biodiversity, that is a situation of healthier ecosystem, and it can create more ecosystem services. So again, those biodiversity alters or influence the supply of ecosystem services. There are different types of ecosystem, particularly agroecosystem, forest ecosystem, grass ecosystem, aquatic ecosystem. And in this presentation, I'll be mainly focusing about the agroecosystem only. And also about the services of ecosystem. We can broadly categorize into 4 services, namely supporting, provisioning, regulating, and cultural. And my presentation will be more or less focused on the supporting and regulating. Supporting, for example, how you can get support for your soil formation process. Biodiversity, how biodiversity can be enriched, or what happens when you when there is a biodiversity loss, what happens, So those kind of ecosystem, and similar way regulating services that what happens when you have pollinators in your garden or in the field crop. Those kind of services we are getting. Let me give you another example of ecosystem that how do wetlands filter water? Okay, so imagine that or you are aware that there are many nutrients, for example, nitrogen and phosphorus, we put as a source of fertilizer in the crop, but sometimes, those fertilizer sources or those fertilizers either over application or random application or mishandling of those fertilizers, they may pollute our water resources, and it threatens the water quality. And lake, river, or wetlands, they can work as a natural water filters. How it can work is that as it encounters the plant, the wetlands slow down the water flow. When the water flow is slowed down, that is less likely to cause erosion, or we can say water erosion, and then soluble water with those nutrients. And I was also visualizing this example from the recently occurred hurricane in Florida. When you have wetlands, that may also help to reduce the speed of the hurricane. Like from the origin to the end point. So when the wetlands are present, it helps to reduce the speed of the hurricane or any other natural disaster activities. So back to this example here is those wetland plants, they can take up excess nutrient and they can convert those nutrients into less harmful form, or some of those nutrients will be utilized by plant, and over the time nutrients are recycled. Wetland plants also absorb the carbon dioxide from the atmosphere. As you know, carbon dioxide is one of the major greenhouse gas sources along with the nitrous oxide and methane. Now let's come back to this picture here. I will check your thoughts in the chat box later, but now let's try to understand this picture. So this picture represents smallholder farming landscape. Okay, this landscape, we can see the agro ecosystem and also kind of like a forest ecosystem here. So this is a smallholder farming landscape showing the role of ecosystem services in supporting agriculture production and food and nutrition security. What happens here that when environmental degradation, shown in the red line here, when environmental degradation from our own activities, okay, if environmental degradation is there, then it threatens the provision of ecosystem. It directly impacts negatively that it may bring the problem with the pollination, problem with the water regulation, problem with the nutrient cycling. And it reduces the smallholder food security. In a similar way, or we can say that if farmers can manage those agro ecosystem to enhance ecosystem services through the ecological intensification, then he or she can be benefited and they may have a more agricultural production, or the food and nutrition security can be increased. So this is the one of the broader landscape that how smallholder farmers, they are working with ecosystem services knowingly or unknowingly. This is a picture that represents the organic farming from the Rodale Institute. So we can see that this is a no-till with a cover crop that soybeans are growing. I kept this picture just for refreshing purpose, that we are going to talk about the organic agriculture concept here. So organic agriculture, sometimes we heard that organic alone is considered as a standard for food production. It is never, okay? Organic production is not simply the avoidance of conventional chemical input. What it is that organic farmers apply techniques first used thousands of years ago, such as crop rotation and the use of composted animal manure and green manure crops, in a way that economically sustainable in today's world. That means organic farmers is a very old practice. And it started with the use of the composted animal manure, green manure. So in a way that it did not use a synthetic one, but it is not the evidence of the conventional chemical input. Beyond the sustainable environment created by organic agriculture, here is the Robert Rodale, the son of J.I. Rodale, who was the founder of the Rodale Institute, that he coined a terminology, regenerative organic. So regenerative organics, that describes the holistic approach, and it encourages continuous innovation and improvement. So when you are thinking about the improvement in a soil or improvement in environmental, social, and economic measures, the Robert Rodale started terminology with regenerative organic. So why it is important is that we can see some of those examples here on the left side. It was about a few years ago news that it forecasted that global topsoil will deplete in 60 years at our current rate of soil erosion. They estimated that in 60 years from now, maybe we'll be losing all topsoils. And obviously, the conventional agriculture, it has a higher agricultural production, but it threatens the sustainability, or it threatens the environmental aspect. And for a little bit improvement perspective, we have organic farming that uses the traditional technique like composting, crop rotation. When organic farming comes with innovation or improvement, and when we can think about the prioritizing building the soil health to fight the climate change, this is the concept of the regenerative organic agriculture. So the number one priority in a regenerative organic agriculture is a soil health, as mentioned by the Rural Institute, or I also found a similar information from another website that called Regenerative Organic Alliance, which certifies the regenerative organic agriculture practices. They also think that regenerative organic agriculture is a collection of practices that focus on regenerative, regenerating soil health and the full of farm ecosystem. So both concept with a regenerative organic agriculture, it prioritizes the soil health. So what is the soil health here? The soil health refers to the capacity of soil to function as a vital living system. And why it is necessary? It is necessary to sustain the biological productivity, to promote the environmental quality, and to maintain the plant and animal health. Again, we can define soil health with a different definition, but again, it depends on you or who you are and what you expect the soil to do for you. You know, for example, for a farmer, the primary function of the soil is to hold enough water, sustain enough nutrients, and provide insect pest control environment to produce sustainable crop. So in overall, the soil health consists four principles with maximizing living roots, minimizing disturbance, maximize biodiversity, and maximize soil cover. I would like to share one of my recent publication. This is an extension publication material that with the title Digging into Soil Health. This is available in AgriLink website. The web link is here, and also you can see the web link in the chat box. Basically, I've been talking about what is soil aggregate, soil quality, soil health, how soil health can be measured, and what type of scorecard are being used in the soil health measurement. So you can read, or you can read this article later. The link is provided in the chat box. So coming to here, that depending upon your farm size and the needs, you know, you may be following these practices. For example, you may have a vegetative cover on your ground. You may be following the crop rotation. You may have already following the no-till or reduced tillage, that minimal soil disturbance. And then also, if your agro-ecosystem also linked with livestock, you may have a rotational grazing system in your practice. Composting is there, and then also obviously the regenerative organic agriculture that uses no synthetic fertilizer or no pesticide. So in a way that you may aid other agroforestry systems or regenerative practices, that how it can contribute for more soil organic matter in your crop, or sorry, more soil organic matter in your soil. So this slide here, that through the early time that Rodale Institute, we have proven that regenerative organic agriculture can sequester carbon from the atmosphere and reverse the climate change. You know, right now the condition of the changing climate, that has several impacts, including reduction in the crop yield and also several negative impacts associated with natural hazard. Let me give you one of the results from the long-term research that conducted at Rural Institute, that how we have proven our research activities to sequester carbon from atmosphere and reverse climate change. So this is the long-term research called Farming System Trial at Rodale, which was started in 1981. And it has a three different approach with a conventional farming versus conventional farming, and then also using the legume based and then manure. Conventional is one, legume based and manure, three different approach, and then it is provided with the two different tillage method of full tillage and reduced tillage. So this is based on the more than 40 years of results that organic practices increase soil organic matter. And especially in the adverse climate weather condition, we have seen increase in the yield up to 30% from the organic practices. And obviously, we have seen the higher soil organic microbial carbon and water infiltration in manure-based farming system trial approach than in a conventional. Let me give you one overview about climate change and then greenhouse gas emission. And then please pardon me that I'm not mostly talking about the conventional practice with the use of the inorganic chemical fertilizers. But again, this picture is just to give you an overview that a typical beef production system, either we knowingly or unknowingly, how we are producing many forms of greenhouse gases from our farm that are associated with the changing climate scenario. For example, you can see here that when cattle are graze in the farm, so those are cattle's either dung or manure or manure on pasture, they may release nitrous oxide or methane. Similarly, the transportation system, they may release carbon dioxide and then nitrous oxide gas. So at a different stage of the farm system, there could be different production of the greenhouse gas emission. And why it is important is once we know the greenhouse gas production, what is happening, then we can adopt the effective management practices. So it is very important to know that at what stage, how much production is happening, or what kind of practices, either that is contributing for more production or the sink properties. And especially, I have been working intensively with a greenhouse gas emission measurement. So before joining Rodale, I was in Lincoln University, followed by the University of Nebraska Lincoln, and then the University of Tennessee. So it's about last 10 years of experience that I have been working with the greenhouse gas measurement, and then using the cover crop, tillage, and other agricultural practices, and then trying to see that what are the good management practices we can adopt so that we can reduce the greenhouse gas emission from our farming practices. And now let me introduce our terminology, which is called carbon footprint. The carbon footprint can be defined as the total amount of direct and indirect greenhouse gas emitted through the life cycle of a product. Let's imagine in this picture here, if we are interested in the meat, when you have 1 pound of beef meat, so how much greenhouse gas emission was produced to make that meat? So in a way that this is a total amount of direct and indirect greenhouse gas emission calculation, and it is measured as a global warming potential. Let me give you another example that one American person per year emits 16 tons of carbon footprint, 16 ton carbon footprint. That means one American person is producing 16 ton this greenhouse gas emission. And if you compare the global average is just 4 tons. So we are producing more carbon footprint than any other global average. Why it is important? Because more emission, definitely it may have a negative impact to the climate change. So any practices associated with agriculture, for example, conservation tillage, cover cropping, or any practice enhancing plant diversity that contribute to increasing soil organic carbon sequestration or reducing the carbon footprint. And obviously, there are some other practices, for example, payment for environmental service program under the title of carbon farming. That is also adopted by farmers, and then many state or government, they are promoting the concept of the carbon farming. So we need to think about reducing carbon footprint, and then regenerative organic agriculture has a potential to reduce the carbon footprint. How? Let me give you our own example that, as I mentioned, I'm based in a Pocono Organic Center in Long Pond, Pennsylvania. Um, Last year, we started our study using 4 different varieties of industrial fiber hemp. Those varieties include 2 from the European varieties, Futura and Xanthica, and then 1 Australian varieties, MS77, and 1 Chinese variety, Hanni. This picture here in the right side is I took this picture last Friday. As you can see that some plants are tall and some plants are short, and then also some plants already reached the maturity stage and some plants are flowering. For example, this one is flowering stage. There are other varieties which reached a maturity stage already. So our purpose for here was to evaluate that based on our agroecological zone, as we are in a 5B climatic zone, which is comparatively cooler zone. So we try to see that what variety worked best for our region. And based on that observation, we are trying to further study 2 different approaches using the industrial hemp. Why we are choosing industrial hemp is that we have seen the literature that industrial hemp can absorb more than 15 tons of carbon dioxide per hectare, more than 15 tons of carbon dioxide per hectare. And this is even more than any agroforestry system, you know. So if we use industrial hemp, and if it is associated with a carbon footprint or if it is associated with a carbon sequestration, obviously this is one of the good approaches that how we can reduce the carbon footprint. And obviously industrial hemp, it is one of the leading crop for reducing carbon footprint. And another research that we are thinking about the phytoremediation properties associated with fiber hemp. So typically the fiber hemp is in good sources for phytoremediation properties, meaning that it can absorb some heavy metals that present in the soil, or it can absorb the contaminants that present in the soil. You know, when the plant is absorbing nutrient from soil sources, at that time it may take or it may absorb some heavy metals and it may transfer from soil system to the plant system. And if you dispose those plants safely, that means like those contaminated soil may be less contaminated from the previous time period, and then those contaminants may present in the plant. So again, if you dispose those plants safely, that you are making your field better. So the phytoremediation properties of the hemp is really suitable to condition, one with those contaminated soil, and also to reclaim the soil with some kind of some kind of bad health, you know. So again, so based on this preliminary observation of our 2 years of observation, we found that at least the Australian varieties and then Chinese varieties, they are performing very good in our agroecozones. And then we are going to use this crop as a concept to reduce the carbon footprint and then to use as a phytoremediation properties. And there is one ongoing research at Rodel that it's called the Climate Smart Commodity Projects. The project has a scope to monitor greenhouse gas emission, soil health benefits, economic impacts, and social barriers to the adoption using the cover crops versus not using the cover crop on their field. For more details, you can go to the Rodel website, and also one of the presenter who was or who is the director of this project, She presented, I think, 2 months ago in the Rodel webinar. So the video may be available in the YouTube. So you can please check, or you can also visit our website for more details. I know I was talking about some good point associated with regenerative organic agriculture, but I was going in details with regenerative agriculture in general, regenerative agriculture versus regenerative organic agriculture. So it's not only there are every good points about regenerative agriculture or regenerative organic agriculture. What I found really interesting, or like things we need to focus on, in that regenerative agriculture is defined in a various way, and there is no widely accepted definition, and it brings some problem. Like the problems is that when there is no clarity in the term meaning, then it is making it difficult to test the claim about its adoption and impact. Similar way, if there are no widely shared understanding about it, then it is bringing another difficult, like when we advocate or when we develop any laws or policies that is related to the in the support of the regenerative agriculture or regenerative organic agriculture, that makes little difficult. So again, I hope those situations will be improved in the future, but right now we are somewhere in, like we have to give a answer in a diplomatic way sometimes, or sometimes like when you ask question, you may not you may not receive the clear answer. So again, like I brought this slide just to make a aware view that there are some confusion, or there is still a place where we need to work. And let me share you my last slide here. This is about that, when we see the ecosystem services, that how we can quantify different types of ecosystem services. For example, nutrient cycling, cultural usage, waste treatment, soil formation, So if you see on our x-axis here, you can see that total global value per year, ranging from 0 to 17. And then on a y-axis, you can see different types of ecosystem services. The meaning is here, for example, let's talk about the nutrient cycling. Nutrient cycling, it may have a total global value of 17 trillion of dollars per year. We are aware or we don't know about it, but something this is happening naturally, or this is being contributed from our agricultural practices. So there is obviously the ecosystem services is very important things that which we require, because it provides life for us, and we need to be careful, or we need to consider for a proper management of ecosystem services. With this, I would like to complete my presentation. Please allow me your questions or any thoughts in the Q&A session. Thank you very much. There is a question that is the 16 tons of carbon footprint per American person on average based on a single or double car family household. Does it take into account of people who work, take public transportation, utilize local farmers, markets, and economic system, grow their own food? So, I mean, for calculation, obviously, it consider all aspects, and this is an average number. And then I'm not sure about the single or double car family, but it is considered that imagine that what transportation system or means you use for your commute, and those things have been considered when they calculate it. And another question is that are there any ongoing discussion about standardizing a definition of regenerative agriculture and what can or cannot fall under it? I think there is definitely ongoing discussions, but I am not up to date with what is going right now. Sorry for this. And another question is that, do you know what country has the lowest carbon footprint per person? I do not know the straight answer, and then those carbon footprint value can be changed from year to year. But again, you can imagine that some countries which have lots of industrialization and then also uh, using the high resources, it can have a high carbon footprint compared to the lowest. It's like maybe some developing countries, they can have a low carbon footprint. Now I'm reading some of your question or thought in the chat box that I was talking. I'm taking a reference of my second slide that when I was showing that large picture of the smallholder farming. So someone says like a beauty of what Earth gives to us, and then a biodiversity ecosystem, biodiverse ecosystem, sustainability, diversity, circular economy. Obviously, yes. The importance of shopping small and local. This picture makes me think about how agriculture can help the environment, right? How farming should be, diversity, environment, food, and livelihood, keep everything in the soil and to help grow stuffs, right? Nature producing food against humans producing food using nature, energy sustainable management, agriculture diversity, removing nature with the intention to grow in a controlled way. Yeah, thank you everyone for thinking about that, what comes in your mind when I was presenting that picture earlier. And there is a question that can organic production of vegetables only be sustainable and regenerative without animal or cereals? So organic production of vegetable, sustainable. So um, in the concept of the regenerative organic agriculture, it considers the holistic approach, So it does not go with a sectoral. So for example, one sector of the crop or one sector of the vegetable, so or another sector of the animal itself. So it considered the holistic. So if you think about the regenerative, obviously not only one sector or one from the organic production vegetable. So we need to think in a holistic perspective. When using manure, is there concern about what the animal was fed that may impact the soil ecosystem? When using manure, is there concern about what animal was fed that may impact the soil system? So definitely that animal feeds, like either it is a grass type or it is a kind of a fodder or even a grain-based feeding systems. Definitely it matters for the concentration or nutrient properties of manure. And sometimes I know we do not talk in the organic system, but in a conventional one, if animal is receiving any inorganic sources, that may have another impact on the soil ecosystem. So definitely what comes as a feed for animal, that impacts to the soil ecosystem. Yeah, there is another question that what specific uh, what instances are having this discussion regarding standardizing the definition? I'd be interested in looking them. So give me a few minutes that I would like to share you the paper that I was mentioning. So uh, okay, it looks like I try to answer most of the question that present in the question and answer session, and also I pick up some question from the chat box. I would like to thank you everyone for joining this webinar with me. I'm also learning, but again, I enjoy with your question, especially that I enjoy thoroughly with that. Is there any ongoing discussion about the standardized definition of a regenerative agriculture? Uh, Sometimes annually those things are happening, but again, some discussion we missed it. So I would like to suggest you that please follow our website, the Rodel Institute, and also other regenerative organic agricultural um, website or platform, I think those kind of platform will be helpful to receive updated information. And again, as a presenter for today, my name is Dinesh Pandey. If you have any question after this presentation or anytime, I'm going to leave my email ID in the chat box. So feel free to give me email or with your question or concern later. Okay, so I'm going to type my email ID in the chat box. So you can see my email ID that dinesh.pandey@ruralinstitute.org. So thank you again. Thank you, everyone. You have a good day. Bye-bye.